So today I'm going to review these two soldering irons. You think, okay, well they look exactly the same. Well, they're very, very similar. There is a slight difference. This is from Zotek. They've sent me these for the purpose of review for free. Now this one here is a single soldering iron tip version. You also get one double soldering iron tip. I guess that means you get two tips applied with it. And also got this other one here. Single soldering iron tip with multimeter, which is what this other one is. So it's got a built-in multimeter, which is unique. I've never seen a soldering iron with a built-in multimeter before. How good is it? I don't know. We'll find out. Stick around. I'm going to power them both up, try them both out. I mean, they're basically identical in most ways, apart from the fact that one's got a multimeter built in. So the actual model numbers are the N1 and the N2. So let's get this out. I already opened this in mailbag and just had a quick look at it, so you know, you may have already seen this a couple of days ago. That's when I did the mailbag video. Now there is actually a little foam pad which goes in here as well, which I accidentally put into this box, so we'll see that in a minute. So we've got the user manual, so have a quick look at this. Product description, you can read all this in your own time. Information there. OLED display, auto power off, stuff like that. Does power delivery, quick charge. Maximum power 96 watts. Obviously it depends on the actual power supply you're using and what tip you're using, that sort of stuff. Defaults to the highest voltage available, that's nice. I think you can actually adjust the voltage as well manually. I think you can, to limit the power. And you've got some controls there and stuff like that. Information about it. Like I said, read this in your own time. More information about how to use it, how to calibrate the temperature. You can do that yourself. You have to tune it, if you need to tune it. So it comes with a USB-C cable, because of its power delivery, so you've got a cable here, I don't know, it's probably a metre long, is it? Let's have a look. I expect they've both got the same cable. And if I double it up, get it on screen, there you go. Full length, it's probably about a metre. I imagine this is rated for the use with this iron, and no more than that. So maybe it's a, I don't know, maybe it's an 80 watt cable or something like that, I don't know, who knows. Because it doesn't draw 80 watts continuously or whatever it may be. It'll be pulsing on and off, because you know, once it's heated up, that'll be it. It'll just be cycling to keep it consistent. But anyway, there's that one. So we've got this sleeve which comes off here, protects it a bit. These bits are interchangeable. Now it's like a T12 bit. This is a T12 bit, this one. Interesting. So they can also do a T65 bit, which is a different length. It's shorter. I'm not familiar with the T65. I'm guessing it's just shorter. I don't know, but it's T12. I've got loads of T12 bits from another iron I've got, so that's good. This is quite a large knife bit that comes with it, as you can probably see there. So that's something I probably want to change to a different one, but I'm going to test with the one that comes with it. The T12s I have here are like aftermarket kind of things. They're not high quality ones, I don't think. So I don't know if we really want to look at those or not. So we've got some controls on here, left and right arrows, and a power and OK. Now this one's got the USB-C port on the back, nothing on the back of it. It's all very plain, not much there. And let's say this is the N1 version. So this won't power up, I don't think, until we actually have power applied to it. So I've got a 5 volt USB-C cable here. Let's plug this in and see what comes up. Okay, it powers up at least on that one, on 5 volts. So we've got soldering iron option, and then we've got settings option. Let's go on settings, have a look what we've got. Temperature degrees C, calibration, return. Okay, that's all we've got in the menu there. Right, so let's just power this up on this supply and see how it actually goes, see if it can actually manage that on a 5 volt power supply. This can do a couple of amps, so we'll see how this goes, eh? Let me get my tester out for the temperature sensing and we'll see what happens. Let's see how we go with a 5 volt power supply. This could be a challenge. 5 volts not ideal, obviously you want to use a high voltage if you can, but let's just see how we go with this. Turn it on, it's heating. And now it's not. It's putting at half an amp. I think 5 volts is not practical. There's that answer. I mean, it is heating, but I'm not quite sure how long it's going to take to actually heat that up though to be usable at a 5 volt power supply. I'm not convinced that's usable like that on 5 volts. I mean, maybe it will get there eventually if you're patient enough. I'm not that patient. Let's try a different power supply. Well, it's been on for a few minutes and it got up to 100 degrees, so it's, you know, it's getting there. Anyway, I've got a proper power supply now. This can do 100 watts, this thing, so, and it does power delivery and that sort of stuff. So we'll chuck it on here and we'll see what we get with this one instead. Alright, turn this back on. Turn this back on. Here we go. Are those real numbers? I don't know. It looks like it might be, because that is actually heated up already. That was pretty quick. Okay, so got it set to 220, we're measuring 244. How do we change the temperature? Here we go, let's go up a bit. 305, let's see how that goes. So heated pretty quickly, that's good. 305 is taking a little bit longer. Looks like it's cycling. So we're shooting slightly. Looks like it's about 15 degrees over there, but we can probably calibrate that out. So this is going to look a little bit different because this is a couple of weeks later. Now when I was doing the calibration testing on the soldering iron to adjust the temperature, I found a firmware problem. So I reported that to Zotek and they sent me another unit with a newer version of the firmware on it. Now the one I had before was a pre-production version, pre-production sample thing, and they do have firmware quirks. It's the sort of thing you come across as a YouTuber or as a product reviewer. You get a pre-production sample and they may not be perfect. I found an issue with that and I reported it to Zotek and they said yep, we've fixed that. The one I had before was 1.2, 1.4, right, so this is a newer version of it. So we're going to do the same testing. Hopefully the issue that I experienced before is now gone. I haven't used this iron yet, so I don't know what we're going to find. Calibration 0 degrees, that's fine and back. So that's exactly the same, no difference in firmware there. Go to iron itself, it's heating. Let's turn this on. Probably should have spun this tip around some more actually before I started this. So we're getting pretty close actually, look at that. 223, it's not too bad, like 10 degrees out there. Okay, let's increase temperature. So last time I did 305, I'm going to do 300. See how quickly it gets there. Looks like this one's undershooting a little bit. Not by much though, it's getting there. There we go, it's actually there. Just going to wait a little bit longer, see what it gets up to. Okay, that's actually acceptable. I'd be inclined to just leave it exactly where it is. That's absolutely fine. I wouldn't bother. Should we do it? I need to test this function. So I'm going to leave this on here this time. So this is when I actually had a firmware glitch on the previous version. So I want to see if anything happens whilst I'm doing this, if this doesn't fall away. Yeah, do it like this so I can work on it. Okay, let's go into settings. Calibration. Drop the calibration down a couple of points. Short down by say 5. And then return. Yeah, there's no issue there with that. So the issue I had with my previous one was that it overshot on the temperature. I think it's just an offset. So if you do 5 degrees, it offsets the display by 5 degrees or something from the actual reading. There you go, look at that, it's bang on now. That's absolutely fine. Thermal capacity tests, well, we could try soldering something maybe. So I got myself out a bit of perf board here, it's just pre-used stuff. I mean, I don't actually have anything to work on right now which needs soldering, so I'm just going to have to do something like this. I just want to see how this handles 300 degrees, which should be fine. I just want to see if it actually solders alright. Thermal mass, put a big blob on here. And it says it's heating still, 47 watts. Interesting, see what I'm doing, maybe. Go. I'm going to put a big blob on here. I mean, that's fine, that's not struggling at all. And you can see it heating. See the cycling there on heating. How real time that is, I don't actually know. And as you can see from the spoke, it's running at 20 volts there. Blob this some more. Do some over here. Try and do it so you can see. Not the ideal angle for the tip, but yeah. Yeah, I mean that's no problem at all. As far as heat capacity on this perf board, That is no trouble at all. I mean, I don't actually have like a test piece for this like STG does, Steve. He has like test boards he has for doing this sort of testing on irons. I don't have that, but this is definitely working absolutely fine there. No issue with heat capacity, at least with this tip. So that's good. So now we look at the N2, which is basically the same as the N1 except it's got a different tip. This is the T65 tip. It's basically like the T12 but shorter. So this is where the T65 comes in. T65 is on the N2, T12 is on the N1. So this will power up. So you see that as E version 1.4. The very first version Zotek sent me was a 1.2 as well. And so this is like an updated video about that as well. I'm going to flip back to the original video later on. I just want to show you this part, see if there's any real differences. So we've got the multimeter function. Warned you about test leads. Didn't measure above 36 volts. So it has multimeter function. So that part I'm going to show you later in the original part. Now, one of the things I did raise, which looks like it's been fixed, is on the original version, the display's being cut off a bit by the bezel. There's like a black bezel here. You can just see that there. It's cutting off the display a little bit. But they've shifted it over now, so it's not being cut off. On the first version, which I'll show in the next piece of video, that symbol's being cut off by the bezel. So they've modified the display very slightly to allow for that in the firmware. So that's fine. You can do DC volts, I'd say up to 36 volts. True RMS, AC as well. And back to resistance again. And in the settings, you can see the setting symbol still slightly cut off. You can see how it's been cut off before. They've still got that slightly offset. Also, I didn't want to modify the bezels, they just modified the firmware to shift the image over, but the settings icon's still being cut off slightly. It's probably not a big deal. So temperature degrees C, USB voltage, which is where you can limit the voltage if you want to reduce the power of the iron, I guess. The other iron doesn't have that, interestingly. Auto power off, again, this option isn't in the other iron. Calibration setting, which is something we need to check, see if we can use that okay. Sol set off. Now what you can do, because this has got an internal battery, you can actually solder off the internal battery. So if you turn this on, then you can use the internal battery to solder. Now that's only relevant for that session, so it doesn't remember that setting. If you want to do this like as an emergency thing, you know, you got an iron and you need to solder something but you haven't got power supply, you could turn it on and use it as a battery iron. Obviously you're going to get limited lifetime from that, you know, limited usage because it's on a battery and you've only got limited battery space in here. But it still get you over a pinch. You know, if you need to solder something for 10 minutes, you'll probably be fine. And you've got the turn option there. Let's look at the iron side of it. Now this is going to say plug it into power, which is fine because we don't have that sol set turned on. So we will plug it into power. Let's see what it's defaulting to. It's probably 220 like the other one. No. 350 it's set to. Okay. Let's see what it's getting up to. What is it actually? There's some fresh solder. So it's 320 or so, even though I set to 350. Okay, let's do a calibration on that. Here, to the settings, calibration. Now because it's low, you actually want to increase it. Let's go, oh it's probably too much. Was it down by 30 degrees? Just under 30 degrees, let's go 28. Go back, and back to the iron. So we set at 350. Put some more fresh solder on that, it's up to 340 almost. Yeah, 350. Perfect, so the calibration worked fine. That's good. Now I'm going to switch to the original video which showed the multimeter usage, unless there's anything different between the two. Actually what I will do is pull that out. And I'm going to show you this other setting which I didn't show in the original video. So let's go in here, settings, sol set, on. Okay, return. Now we're running for the battery. So this is battery power running this now. Let's just put some more fresh solder on there. See it comes up to 350. Now interestingly, when running from battery, it looks like it is running slightly colder. You would think it'd be the same, wouldn't you? Not much in it, I don't know, it's gradually getting there, maybe it's because it's got slightly less power. There we go, it's there. It is there. So, but yeah, obviously you're going to get limited lifetime for the battery. Only use it as much power as you need to. Set 300. And it's going to let it come down, it's dropping down, yeah. You can see the discrepancy between display and the actual temperature there. This problem with when you have a single set point, you don't have like a dual set point. Now it's heating again. Obviously it's like a PID control thing there where it ramps the temperature up and down to allow it to stabilise. And the control loop seems to be a little bit slow, but it does get back to 300 again. That's fine, it does manage it. Okay, but that's on battery, so if you need a battery iron in a pinch, this would be perfect for that. So let's turn this thing off. Clean the tip. And return to the previous part of video. So this is the N2 instead, which is different. Try not to have the lights reflecting on it at the same time, but there you go. So it's got, what modes have we got? DC volts, AC volts, maximum of 36 volts. Remember that. Must not exceed 36 volts. Resistance and continuity. So that's alright. Most common features you might use. DC resistance and continuity. What's this accuracy there? 1% plus 3 counts. 3% worst case there. Yeah, 3% worst case. 0.5% DC plus 3 counts. So that's alright. It's reasonable. I'm not sure what digits it is actually. Probably says somewhere. And 100 degrees to 450 degrees for the set temperature. 5 volts, 20 volts power supply, maximum 75 watts. And it has a built-in lithium battery. 800 milliamp hour battery. Plug in the power. So you got N2, yeah, so it's charging. It's half charged, it tells you what the battery state is, that's nice. If I unplug it again, power it on. Here we go, 1.2. Let's try multimeter mode. Some Chinese, or I can't read. Yeah, that display's been cut off, like that little black bezel around the display is too small. So you got the ohm symbol there. It is a complete ohm symbol. You can see it if I do it at an angle and bring it down, it's been cut off by that. So Zotek, you need to fix that. The display's been cut off by that bezel there. It makes it look a bit, yeah, even the bottom's a bit close, maybe. Top's looking okay. Maybe the display's offset. Maybe it's not, I don't know. Yeah, I'm just trying to sort of determine whether the display should be moved over a little bit. Maybe it's not quite sitting in the right place. But in this case, it's cutting off the digits. You haven't looked at the settings on this thing yet. Got temperature degrees C and Fahrenheit. USB voltage, which is what I was playing with before when I first used it. So that's what negotiates with the charger. Auto power off 10 minutes, that's fine. Cal point, which is what I've been playing with a lot. Sol set and return. Let's look at multimeter. Some Chinese, which I don't understand. Multimeter part. So let's unplug that part. So we use this. So I think we shove this in here. This is used like that as a probe, and then we have this piece, plug that in there, and then you have your positive negative probes for doing multimeter testing using this. So let's test some stuff, shall we? See if it's actually any good or not. So over here my calibrator. Might as well use this can reduce voltages to test this with, so we'll do that. It's going to be a little bit awkward. We've got to sort of shove the probes in there to see if it's going to manage to make a contact. It's not ideal. This is an expensive calibrator. There's no doubting this thing's outputs are correct, or it's correct enough to test this thing. So let's start on voltages. DC volts do 100 microvolts. I doubt that'll show up. It is, but it's showing up as kilo ohms. 100 kilo ohms it's showing up as. Showing as resistance, not voltage. Not quite what we want, is it? So 1 millivolt, It's also showing as resistance 10 millivolts. Still showing as resistance 100 millivolts. Still showing as resistance 1 volt. It's finally showing a voltage. Okay, let's try bringing this down. Now this is the problem with these smart meters. I've seen this on multiple smart meters. When they've got auto ranging, they can't identify a voltage. There we go. We've got 700 millivolts going in. It's just sitting there saying auto, which doesn't know what the hell it's measuring. Yeah, anything below 1 volt on these auto meters, like 900 is like the margin there. Yeah, so anything below 1 volt is basically useless on these things. 1 volt can actually measure. So you need to bear that in mind when you're measuring stuff with these automatic meters, not just this one, but all these smart meters. Actually, I think all of the ones I've tested, they've all had issues below 1 volt. Below 1 volt, forget it. Another little update to this little appendum. So I showed this on the calibrator, obviously, but I've found a way of solving the issue with the low voltage. So what I was showing was the auto range on this. Right, let's do auto. If you go to manual DC voltage selection, then shove it in there. This is a position reference. 100 millivolts. No problem whatsoever. And it's actually quite accurate. So if we go down to say 50, that's looking good. 10 millivolts, also looking good. Let's go 1 millivolt. 0.8 is very slightly off there. But that's okay. Well, 0.9, there we go, it's just about there. So that's actually pretty good. So that was that issue I was having before. So let's do 500 millivolts. Let's do 501 and 800. There's 800 and 1 volt. There's 1 volt. So that's all good. So yes, that's a solution to that, is to actually not use auto mode, because that's a common thing that these things have, is auto mode. Yeah, that changes modes. Right, so auto, DC. Do DC. That solves that problem. So this is measuring 3 counts, 3 counts high. Okay, let's go 10 volts. 10 volts, 1 count high. Let's go up to 19. Don't forget it's going to 36, so I'll be careful not to blow it up. So I've got 19 volts going in, 3 counts high, so that's okay. I mean, it's now should be doing 9. See how slow that is to respond? It's a bit slow. Okay, let's do AC instead. Let's start at 1 volt AC. There's no point measuring less than that, is there? I'm doing 1 volt AC, 1 kilohertz. Finally got there. That is really slow. Do 100 hertz version instead. That's the more likely frequency to be measuring. It took ages to get there, and it's not right. 10 volts AC. Okay, got that. 1 kilohertz. You got that in the end. 10 kilohertz. Can't see 10 kilohertz. Let's bring it down. Let's go 5. So it's 10 volts AC going in. 5 kilohertz measuring 6 volts. 3 kilohertz measuring slightly low. 2 kilohertz. Yeah, so 2 kilohertz is the frequency limit of this thing on AC, on the upper end. Let's try that lower end. So we know 100 hertz works. That's 200 hertz. 100. Let's try 50. 50 still working. 20. And 20 appears to still be working too, but it's measuring low. Okay, that's that part. Let's do resistances now. So resistance, let's try 10 ohms to start with. Yeah, okay, 10 ohms is beeping. Okay, so it is doing these ones okay. So 10k, 100k, 1 meg, 10 meg, 100 meg. Can't see that one. Well, that was basically what I expected. The accuracy was kind of what I was expecting on it. Interesting setup. How do we get this thing apart? I want to look inside it. I wonder how we get into this thing. I think that end will come off and it will slide out. There we go. Managed to get in there. There's the lithium cell. It looks like it will slide out, but it looks like I might need to peel the screen off. You can see inside there now. That's what's on the end. Looks like I need to lift up the screen to get the buttons out of the way, maybe, so I can slide it. Maybe. I'm not quite sure. We'll try it. Something a little bit sharper. Try and get underneath the screen. There we go. I'm guessing this will allow me to lift it up. There we go, there's the buttons. What's under here? Anything? Ah, that bit slides off. There's the screen just sitting in there. Look at that. There's the screen just sitting there. Right. If I push it all the way to one end and I'll push this piece back on again, we'll see what happens. Okay, maybe I won't pull it right out. That lithium cell slid in through a little slot, look. Maybe it goes out the other way. That way. Like that. And there's this circuit board inside there. Protected cell, is it? Okay, well this is why it's not got the T12 tip, because obviously it needs all the body for the battery itself. See what it is? FC-M32F. Blob chip, probably for display. Yeah, not much to see in there, is there? Okay, well I've got to what I wanted to do, which is to see what the display's like. So I want to get this display back down and make sure it's pushing all the way that way to make sure it's definitely not misaligned, causing that issue on the front here. I might just put a bit of adhesive or something just down there. Maybe just a little blob to hold it in place. I'll put it back together. Right, let's try sliding this back on. The thing is, I'm trying to rush because there's supposed to be a power outage today, all day. So I'm trying to get some video recorded before the power goes off. So if you look at this, when I'm sliding this down, the cutout on this is actually smaller than the display by a fair amount. That's surprising. Let's turn it back on. This bezel was actually cutting that edge of the display off. Yeah, the cutout as itself is too small. So I actually use this deburring tool to make this opening a little bit bigger. And now, everything is visible. But it may not help that much, depends on what the little plastic bezel on the front's also doing, what that's covering up. But I think that is only part of the problem. That's definitely better. So I'm going to run some black marker around the inside of that to cover up that edge, and I'll put it back together. So let's put the sticker back on the front with the actual label with the buttons. Alright, so that's all that. And it's still cutting it off, but it's that little black bezel around the front there on the actual sticker which is causing that problem now. You could probably scrape it and get that off. You could actually end up making it look worse. So I've just tried to pull it this way as much as I could when I put it back on, to try and get this end more exposed than this end. Who cares about the battery symbol? I mean, if the battery symbol is cut off a little bit, so what? Home symbol was still cut off. Yeah, it's not much better. I mean, from this angle we can see it better now. I've made an improvement. Before that'd be completely cut off. So I have made an improvement, but it's this plastic on the front which is cutting it off. Well, I've got it back together, but is it really any better? I don't know. Marginally, maybe. Now the frame itself isn't in the way. Literally a couple of millimetres. Even a millimetre would have been enough. Look, probably 1 millimetre would have been enough. Obviously Zotek sent this to me for review for no cost, right? And I do try not to be biased. I've never seen anything with a multimeter put in like this. Interesting idea. Limited functionality. So you can't do anything more than 36 volts, otherwise you risk blowing it up. Continuity beeper, it has one, but it's really quiet. It's not that noisy. And obviously this display thing on this one. The other one doesn't have it because I think it doesn't use all the display because it's the slightly different version. So Build quality is excellent. Firmware, I mean, firmware stuff can always be fixed. It's just firmware stuff. And I imagine these can be firmware updated somehow. I should try plugging it into a computer and see if it comes up as a drive. Let's do that before the power goes off. We'll try with this cable. I don't know if there's actually a data cable on it. It might be a power cable only. Yeah, it didn't show up at all. I plugged it in using the supplied cable. So it may not be firmware updatable. If that's the case, this could be a problem. So you have to choose which one you're going to carry inside the unit. There's no storage to carry that extra piece for the multimeter, but I might even use this bit for the multimeter. Maybe you can use that. Should we try it? Just quickly try that, see if it actually works like that. Maybe you don't need to have the special probe. That's working. Maybe you don't actually need the special probe, you can just use a soldering iron tip. That actually works. We get voltage source. PDVST Mini, 1 volt. We know that's close to the threshold. Stick that in there. Get a connection. That's measuring 1 volt. You can actually use a soldering iron tip instead of an actual probe. So that's not an issue after all. You can use a soldering iron tip. I'm not sure how reliable it'll be, but it works. Well, thanks Zotek for sending this to me to review. As a small portable soldering iron you plug in with USB-C, it's great. Nice and compact, nice short distance from your fingers to this. The stands are okay. I mean, the stands work. You know, you're not going to expect much from that, are you? It's just to get the thing off the desk. Although, like this, is also fine. Ain't going to really matter, is it? But you know, at least like this, it's going to be kind of contained. Obviously, got the little sponge that goes in there too, which you're supposed to wet. I think they're relatively cheap. It's like $30 or $40, something like that. So for that price bracket, I think yes, I think they're worth buying. There's no carry bag for them. It'd be nice to have a little carry pouch to actually put these things in, so you can, you know, keep it all together. Like this probe, you don't lose in this. If you're carrying this thing around, you know, with the cover on it, which is nice. That's a really nice cover. But you end up losing this cable, and this is unique, right? This is USB-C to this. I mean, this is a unique cable. I don't even know how it's wired up. It's probably just going to the ground, to the 0 volt side of it, I'm guessing. I reckon there's a risk of losing this because you've got no storage pouch to put this stuff into. You know, if you've got these accessories to go with it, then you should probably have some kind of storage carry pouch to go with it. If you're using it on your bench, it probably doesn't matter. But if you're going to be carrying it around, you're going to need a bag to put this stuff into to keep it together. Out of the two, I prefer the N1, and that's also cheaper. That's what I'm saying prices. These are New Zealand prices, by the way. So that's $30 New Zealand for that one, and this is $40 New Zealand for this one. It's $10 difference. You think, oh, well, I might as well spend the extra $10 to get the extra functionality. Well, maybe, but then you've got the different tips. You've got the T65 tip to the T12 tip. T12 is more common. Like I said, I've got a bunch of T12 tips already, and they will work in here. Just drop them straight in, done. Multimeter function could be useful to some people. You have to really think about what you're going to be using it for. Are you really going to use the multimeter function on it? Maybe you will, maybe you won't. Maybe you want it as an emergency iron. In that case, you may want that functionality. You know, keep it in your car or something like that. I don't know, whatever, maybe. But it's a unique concept. I mean, I've never seen anyone do this before, so good on for giving it a try. Implementation's okay. The actual multimeter side works beautifully, but apart from obviously below 1 volt, because that's a common limitation with the sensing of these things, because they assume it's a resistance below 1 volt. I don't know, make of it what you will. Draw your own conclusions. I'm kind of struggling to figure out what to summarise as you can probably tell. So thanks a lot, Zotek, for sending these to me, and check out links down below if you're interested in these. Other videos down below to watch. Subscribe over here if you're not already subscribed. Patreon support link over there if you want to help support me on Patreon. A couple of dollars a month all helps the channel. Catch you later.